Hey guys, so in this recording, we're going to prove that the covariance between two random variables x and y equals 0 if and only if these two variables are independent. Okay, so first of all, we begin by noting the definition of covariance. So we know that the covariance of two random variables x and y is defined to be the expected value of the product of their deviations from their population means. So I know that sounds a bit scary, but once we write the definition, it becomes quite easy. So covariance is denoted by sigma with the subscript xy, and this is defined as the expected value of the product of their deviations from their population means. So mu denotes the population mean, so x minus mu x times y minus mu y. Okay, cool. So the next step is to rewrite this expression right here as follows. So we're going to rewrite this expression. So this can be rewritten as the expected value of x minus mu x times the expected value of y minus mu y. And basically what we've done here is that we've rewritten the covariance as the product of the expected values of its factors. Okay, so once we've rewritten this in this manner, we can proceed as follows. Now, first of all, remember that we're going to be using the expected value rule. So if you don't remember them, you can visit my videos where I explain the expected value rules. So using the first expected value rule, we can rewrite this as follows. This becomes expected value of x minus the expected value of mu x times expected value of y minus the expected value of mu y. Okay, cool. Now remember that the expected value of mu x is simply going to equal mu x, and similarly the expected value of mu y is simply going to equal mu y. Why? Because these are just constants, right? So using expected value rule, first of all, let me just write what I have done here. So in this particular step, we have used EV rule 1, and in the next step, we're going to use EV, that is expected value rule 3. Okay, and also we have to note that over here the expected value of x is simply equal to mu x, and the expected value of y is simply equal to mu y. Therefore we can rewrite this as follows. So this becomes mu x minus mu x. So this is using rule number 3, expected value rule 3, times mu y minus mu y. Okay, so we can see that this is going to simply equal 0 multiplied by 0, which is equal to 0. Therefore we can see that the covariance between x and y equals 0.